I was saying, man, I'm so old. I remember when cereal had real names that were honest. Like it used to be called sugar corn pops and sugar frosted flakes. They took that word sugar off the label a long time ago because people started going, well, that's not very healthy if it's got all that sugar. So they had to rename a lot of cereals and take off that sugar name if it was on there. So I guess cinnamon gets along with it because cinnamon's not considered unhealthy. So they can be cinnamon toast crunch. But yeah, there's no sugar corn, there's no sugar frosted flakes. That doesn't exist anymore. If you find a box like that, man, it's an antique. It means the cereal's really, really old. You don't want to eat it. So let's see. All right, Honey Nut Cheerios. We got a Cheerios fan there. Cinnamon Nut Toast Crunch seems to be the one I'm seeing the most often. That seems to be the hands-on winner this morning. What is it, like 6 people or something that said that? Yeah, that seems to be the popular cereal, Cinnamon Toast Crunch. Now everyone's hungry for breakfast if you haven't eaten, because I put all these cereals up. Made me hungry. I'm like, man, I haven't eaten yet. So that's where we're at. All right, let's go over to our programming and see what's going on this week. Foundations of programming. Let's look at our grade screen as usual. Well, we have while loops. Then we've got a lesson on creating function next week and our final exam. So we're right at the end here. So for loops up. Fake student didn't turn in his for loops program. He's got to get. I saw several of you have your program turned in. It's not graded yet. I will get it graded hopefully today. I don't know how busy I'm going to be today yet, but hopefully I'll get that graded today real soon. Get that grade in because you want credit for it. If you get that turned in, that's a 100-point program. But let's look at while loops. And then next week we'll be creating functions followed by the final exam. So we're getting right to the end of it for the semester here. All right. While loops lesson right here. This is going to be very similar to for loops. So if you understood your for loops, it's just a little bit different format. And we're going to work very closely to the same thing. I mean, a loop is a loop is a loop, right? So, all right. Boundaries are a good thing. When you're full, you stop eating or you gain 50 pounds, one or the other. When you're tired, you start sleeping, hopefully. I know some of y'all push that for a little bit. I did when I was a teenager. When your phone dies, you plug it in. That one definitely. I know you got that. At least you tried to follow the boundaries. Whether it's your stomach, your energy level, battery life, everything has a boundary that indicates something needs to start or stop happening. So in programming, boundaries are going to work pretty much the same way. So we're going to compare for and while loops this week. And we're going to explain how the while loop works and identify the boundary conditions needed for while loops. And then we're going to use a while loop to perform repetitive tasks, like we used a for loop to perform repetitive tasks. Loop types. All right, so when you want Python repeat in action, you use a loop. So here was the for loop that we looked at last week. For x in range 0, 1, 10. Well, that ain't going to do very well, right? Because it starts at 0 and goes to 1 by tens. Let's look at a while loop. A while loop, on this, you set like a variable equal to 0. So we said, okay, we're going to set x equal to 0 before the loop starts. And then you're going to say, while x is less than 10, or however many times you want it to loop, and then somewhere in the loop, you say x equals x plus 1. And so you add 1 to x in the loop. If you forget that statement, your programs are going to be caught in a loop forever, and it won't ever end. If you forget to change the value of x, it'll never reach its boundary. It'll never stop. So that's the important thing about a while loop is with a for loop, it's built in. You give it the starting, the ending, and the count. Or you can just give it one number and it automatically counts by ones and it automatically starts at 0. But it's built in with the for x. With a while x here, you have to do something in the loop to change that value. Let's look at that. So here's a comparison. For loops and while loops. So for loops, they repeat for a set range of values. The loop variable is given a start value, and it's best used when you know the exact number of repetitions needed. So for a while loop, it repeats while some Boolean condition is true. That means greater than, less than, greater than or equal to, that type of thing. The loop variable is assigned a value before the loop, and it's best used when you do not know the exact number of repetitions needed. A lot of times you don't know when you use a while loop. It's like, okay, I'm going to start at this value, and then I'm going to be calculating this in this loop. And when it gets to this point, it's when I want to stop. But I don't know how many times it's going to take to get there. And let's see, our Venn diagram has in the middle things that are true of both loops. They both repeat a block of code, and they both will stop once the condition is false, right? Like the while loop is while x is less than 10. Well, that's true. We'll do the loop again. That's true. We'll do the loop again. Oh, now it's 10. This is false. I won't loop anymore. So, all right, let's go to page 3. Worth your while loop. Say a little play on words there. Eh? Okay. Let's see. Imagine your friends are binge watching your new favorite show. Like you ever do that? Do you ever like binge watch? Okay. There's 7 seasons, and you're going to watch until you see the series finale. It's going to be a long but epic weekend, baby. We're going to rock it out. But something keeps happening. Every time an episode ends, there's a pop-up appears on the screen, says, are you still watching? Yeah, we've seen those, right? We binge watch. You haven't touched the remote in a long time. The TV's just playing episode after episode. And finally it goes, okay, you're messing with me. You're not watching this anymore, are you? You've left, and I'm just repeating. But it hasn't. Are you still watching? It's been 16 hours. You're covered in chips. Really think about it. I like that. I would enjoy that pop-up more than the usual one. This is when a while loop would be useful. You have to ask yourself, while I can stay awake, go ahead and keep playing the show. Or while there are still episodes left, keep playing the show. That way you don't have to know how many episodes there are, right? And just, keep going. If it could tell when you fell asleep and would stop automatically for you, that would be great. Hopefully we'll get there someday, right? Where it can tell we're asleep. So we use while loops to repeat actions when we cannot find the number of necessary iterations easily. Like if we know there's 7 seasons, do they all have the same number of episodes? Do we know exactly how many episodes that is? We can just say, while there's still more episodes, keep going. See, that's the difference in a while and a for loop. The reason you'd use a while instead. So here's the important syntax points to be aware of when you're writing a while loop. The statement begins with the keyword while. Well, that makes sense. That's why it's a while loop. The test condition goes inside the parentheses, like you see right there. Answer equals y. And the statement ends with a colon at the end. Kind of like when we define main, we have to have that colon at the end. And the code inside the loop gets indented. That's the same as like with the for loop. You have to indent everything that's supposed to be inside the loop so it knows, oh, that's part of the loop. So here's an example. Answer equals y. We set answer equal to y. Now here's something interesting. We haven't encountered this before. When we're using Boolean to check less than, greater than, or equal to, you have to put 2 equal signs if we're checking to see if it's equal. Does the answer still equal yes? We have to use 2 equal signs because if we just put 1, that would automatically assign y to the variable answer. We don't want to assign y. We want to check to see if it is. Does this equal y? So 2 equal signs are necessary. So it says, while the answer is yes, we must be doing the turtle. We named our turtle Trixie. So Trixie's going to make a circle and then turn left 25 degrees. And then there's an input statement inside our loop. Would you like to draw another y or n? So if they type y, it'll go back and draw another circle. If they type y, it'll go back up and draw another circle. They said y, it's going to go up and draw another. You know how it works. That's a loop. Until they hit n, it will keep repeating. So that's one of those where you don't know how many circles the user wants to draw. So we're not going to use a for loop because a for loop is going to designate this is how many circles you're getting. The while loop allows that input statement in the loop to change the value. So a while loop just needs to know what action is it doing And what are the conditions for doing this action? In this case, as long as the answer is yes, why? Keep drawing circles. So there are a few instances that work like while loops. Like while it's raining outside, use an umbrella. So that's on the condition that it's raining, you'll use an umbrella. Otherwise, you'll stop using an umbrella because you look silly. While there's still ripe fruit on the tree, pick it. And while there's not, you don't pick it if it's not ripe. This logic works both ways, right? While there's a ride in progress, do you know this one? Keep your hands, arms, feet, and legs inside, right? This should always be true. While the ride is in progress, don't stick anything out unless you want to lose it. While I'm following you on Instagram, I can see your photos. But if I unfollow you, not so much, right? That's how while loops work. There you go. It's not that show, that's how. That's the only thing about hashtags. All right, so let's look at an example of a while loop. Boolean conditions. Yeah, we need to understand those. So it uses Boolean logic to figure out whether it's true or false, and it'll keep repeating as long as it's true. So here are the Boolean conditions that you would use. Here's how they look in algebra, right? Less than or equal to looks like that. It's a less than with a line underneath the less than. In programming, you type both symbols, less than and equal to. You type less than equal. Here's the one that gets a little tricky. Equal, you got to put two equal signs. And not equal, you put an exclamation point with an equal sign. That means not equal. So you may want this in your notes, be able to refer to this page. Remember, you can use your notes on all programs, all assignments, all tests, anything. So you may want to write those down until you know them really well. But let's look at their example program. All right, read the code, try to predict the output. The while loop. So we define our main function. We set x equal to 0, and we said while x is less than 5, print x. Then add 1 to x and repeat until this is no longer true. In the main. All right, so this shouldn't be too bad to predict this, right? So it's good. The x is going to be equal to 0, and it's going to hit the loop, and it's going to print that. So we expect it to print 0 because that's what x is equal to the first time through the loop. Now we're going to add 1. So x will now be equal to 1. And it's going to go back to the loop. It's going to check, is x less than 5? Yes, x is 1. So it's going to print x, which would be equal to 1. And it's going to add another one on there. Now x is going to be equal to 2. Is that less than 5? Yes. So we'll print x, which is now 2. And we will continue that loop until it equals 5. And then after it gets to 5, it'll say, is x less than 5? No, 5 is not less than 5. So it will stop the loop and go on to the next line of code, which says in the main. So let's run that and see if we get what we expect, right? We expect it to print the numbers 0 through 4. There it is. It repeats while x is less than 5. But once it gets to 5, it stops. It doesn't print anymore. It doesn't do the loop anymore because it got to where this was not true any longer. Since 0 is less than 5, the block of code within the while loop is executed. Continues on. So let's look at their next example. Read the code, try to predict the output. Well, right now it's the same code. So if we run it, we get the same results. It says modify the range of the while loop so the count is from 1 to 10. So we want it to print 1 to 10. So we know the first thing we need to print is the x equal to 1. So we need to change our value of 1 and change our while loop to be x is less than, what's it need to be? If we want to print 1 to 10, we need our loop to print as long as x is less than 11. Because we want it to print 10, we want to print 1 to 10. So it's not going to stop until it gets to 11. Then it'll stop. So let's run that. 1 starts at 1 now because we changed this value. and it printed 10, and that's where it stopped. All right, so the while loop's not too difficult. Just understand it works different than the for loop because it depends on the condition of what's happening inside the loop. Let's look at another one. Okay, we have the turtle. We're importing our turtle and naming our turtle Rosemary. Oh, Rosemary, it sounds like a dainty little old turtle. She's going to be carrying her purple marker. She's going to be going at a speed of 10. She's going to pick her pen up, go to the position 050, and put her pen back down, and Rosemary is ready to go. And we're telling at the beginning, num circles equals 10, and x equals 0. So while x, which starts at 0, is less than number of circles, which is equal to 10, I want Rosemary to draw a circle. And I want it to be 40 pixels. And then left 360 divided by the number of circles. So since number of circles is 10, she's going to go left 36 degrees. And then we're going to add 1 to advance the loop and see, is the loop number still less than the number of circles? Main. So let's see what happens when Rosemary picks up her little purple pen and starts drawing circles here. We expect 10 circles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 circles. So she started at the position 050, set x equal to 0. That's less than 10. So she draws 1 circle there. And then turn left 36 degrees so that the next circle will not be on top of the old circle, but 36 degrees left of that circle. And she draws another one after we add 1. Now it's 1. And she keeps going until it equals there. Now 36 degrees times 10 is 360 degrees. That's why it made a nice symmetric shape that looks complete all the way around because it drew 10 circles. Here we can run it again. The 36 degrees difference every time it draws a circle. So we got this lovely flower pattern using the while loop and stopping it once 10 equals the number of circles. Right? Number of circles is 10. So when the x gets there, when it's 10 is less than 10, that's false. All right, let's look at another example. The while loop, define main. We said total equals 0. Okay. While the total is less than 20, this says num is our variable, num, equals integer input. Please enter a number. Then we'll print that number and we'll add it to the total. And once the total is 20 or larger, it will stop the loop and it will print what the total is. So let's run this program. So it pops up this window and it says enter a number. Okay, let's enter 5. I hit OK. Oh, now that window pops up again. It says enter a number. 3. Okay. Oh, now it ends up again. Let's say 0.5. That should create an error, right? Because this said integers. And I put in a float value. So maybe this should be, say, enter a whole number. So think about that. If you tell an integer, make sure you're telling the person to enter integers. All right, enter a whole number. Let's start again. Enter a whole number. Well, 5, 2, 6, 1, 8. Oh, once I got to where the total was 20 or greater, it stopped the loop and it prints out the numbers I entered. 5, 2, 6, 1, 8, and the total is 22 when you add all of those together. So that's where a for loop would not have worked, because the for loop is set on a specific amount of loops that you enter with the loop. You don't know how many, because you don't know what size numbers are going to enter. You may hit your total of 20 after the first number. You may take 20 numbers to equal a total of 20. So you just don't know. So this is where a while loop is more appropriate than a for loop. So it just depends on what you're doing inside the loop. And if you know how many loops you're going to need. Let's look at their fifth example. Print, let's find the total. Okay, so this is another mathematical one. It starts out with the total, set the total equal to 0. We got to establish our total variable. Answer equals y. Okay, it says, so while the answer equals, remember, you got to have two equal signs when you're testing a Boolean condition. While the answer equals y, have somebody input. Please enter a number. Again, I'm going to add whole number because they put integer. Please enter a whole number. And it'll print whatever number they enter, and it'll add it to the total. And then it says, would you like to add another number? Yes or no. If they say, yes, I would like to add another number, it'll go back to the loop again. Because as long as this is true, it'll keep looping. As long as the answer equals y, it'll keep looping. Would you like to add another number, y or in? Notice they put y or in. They didn't put yes or no, because if you put yes or no, the person's going to type yes. And this is not going to be true anymore, because yes does not equal y. So if you only want them to enter y or in, make sure you put that in your input statement so they know what is expected of them to enter. And after it gets through and they enter in and gets out of here, that's what's going to print the total. So this would be useful if you have a whole string of numbers. You don't know how many numbers you're adding up together, and you can write a program like this. So run, enter a whole number, 21. You want another one? Yes, I got another number to add, 56. Yes, 3. Yes. Oh, I put the y before I hit enter. So I entered 3y. So I caused an error. Let me try that again. 22. Yes. 31. Yes. 54. Yes. 99. Another number? Yes. I'm going to enter 5,214. Any more numbers? Nope. That's all my numbers. I can say no, and it'll end the loop. Let's find the total. 22 plus 31 plus 54 plus 99 plus 5214 is 5,420. Useful program to add a string of numbers. It could repeat one time. It could repeat 1,000 times, just as long as someone keeps typing y when they're asked if they want to add another number. It'll loop on and on and on and on. All right. Let's look at another one. Import turtle. Trixie is our turtle. We've set her speed to 10. Here's another one. Answer equals y. So as long as they keep answering y, it'll continue. Now this says number of circles. Input, how many circles should be drawn? Now that's going to be an integer because no one's going to say draw 2.5 circles. The diameter. What is the diameter for the circles? And so they get to choose that. And then Trixie color is set to input what color is the turtle. So this is kind of cool. So everyone that runs your program could have entirely different circles on the screen. All right, so now we got another while loop inside that while loop. So after you enter this, now it says set x equal to 0. And while x is less than the number of circles, which is what someone entered, it's going to make a circle of the diameter that they entered up here, 360 divided by the number of circles, because it's going to make a flower pattern. And then it's going to add 1 to x and go back up and see if that's less than the number of circles. And after it kicks out of that loop, it's still inside this loop where it says, would you like to draw another? That's where you put y or in, and it says, okay, are we going to do this again? Is it still equal to y? Then let's go through the loop again. Let them choose the number of circles, let them choose the diameter, and let them choose the color of the circle this time. And we'll do that. So let's run this because that sounds pretty interesting. We got a loop inside of a loop. All right, how many circles should be drawn? This is that first loop. We're going to say draw 5 circles. What's the diameter? Let's draw them at a 50. And what color is the turtle? We'll make these red. Okay, so we drew. Would you like to draw another? Yes, I do want to draw another one. How many circles are we drawing? This time I want to draw twice as many. Let's do 10. What's the diameter? I'll make these a little smaller, 40. And let's make the turtle green this time. So look, now we're drawing twice as many circles, a little bit smaller than the red circles. Yes, let's draw another. Let's draw 20 circles this time of a diameter of 30 and make those blue. Circles inside circles inside circles. Draw another. Yes, we're gonna do one last one. How many circles we draw? We're gonna do 100 circles at a diameter of 10, and these are going to be yellow. So we're basically filling in the center of it there with 100 circles, just 3.6 degrees difference between them. So after it gets through, our speed's a little slow for 100 circles, but we're kind of filling in the center of our circle with a more of a solid circle. Almost there. All right. Do I want another one? No. Now the loop ends. So the first loop is where it asks me the questions, and then it has a loop to do what I say. I said, draw 5 circles this size. So it did that loop, and then it comes back to the first loop and checks to see, did I still want to continue looping? And I did. So I did the green ones, and then I did the blue ones. I did the yellow ones, and I said no, and it quit. So that's an interesting. Now, notice how you have to indent. This loop, you have to indent everything to this level. So that includes the second loop because it's part of the first loop. But the second loop, you got to indent inside there. What is inside this loop? These 3 lines. All right. Notice this is outside. After this loop finishes, then we ask it, would you like to draw another? But that is indented to be part of this loop. So indentation gets a little tricky when you put loops inside loops. But yes, Serenity, you were right. That last one was like a calculator, but it only did addition. Right. Let's see. Let's look at the last example they give us. So we start out importing our turtle, starting our main function. We name him Joe. We give him a speed of 10. Shape. Turtle shape. Look, there's options here. Turtle, arrow, circle, square, triangle, classic. We haven't used this command before, but it's making the shape of our turtle. And then we're going to pick our pen up and move him over to 0, 30. Okay, so that's all just setting up our turtle. We set our answer equal to y and start our first loop here. Answer, is the answer still y? Well, yes, it is the first time for sure. So I'm going to set the size to 1, very small. Ask the user to input a color. So Joe the turtle will be whatever color they input. And then says, please enter a shape. So we can make it a different shape. A turtle, arrow, circle, square, triangle, classic. So we entered the choices in the input statement that we set up here. Options. So this is interesting. So now we did a for loop. This one's going to loop 15 times, 0 to 14, right? And Joe is going to stamp whatever shape we told it to be, and then add 2 to the size, move forward that amount, and turn left 30 degrees. And it's going to do that for 15 times. And then it'll ask, do you want to continue? And it'll go back to this loop again, back up to here, choose a different color, choose a different shape, and it'll do 15 of those till we end our main function down on line 23. So let's run this and see. This looks interesting. Okay, there's a turtle shape. We set him to the turtle shape first. That was what we did way up here. Shape, where we set it turtle, and then listed options. Enter a color. Let's make him blue. Let's keep the turtle color. Okay, so it drew 15 turtles. Yes, I want to continue. I'm going to do crimson. And let's do a triangle this time. Oh, look, now we did 15 triangles. Each time adding 2 to the size that we move forward. Moves forward stamps, move forward stamp, move forward stamp. But each time it's 2 further than the last one was. Let's continue again. Let's look at another one. Enter a color. Green. Let's do classic. I don't know what classic is, but we're going to do a classic shape. Oh, it's like an old mouse. Okay. Do I want to continue? No. Now I can scroll up. That's kind of like some mouse used to be. You'd have a pointer type of thing, kind of like a paper airplane looking shape. That's what classic is. But see, as long as we kept saying yes, we could choose a color and a shape, and it would make 15 of them in this spiral fashion. So it uses a while loop and a for loop. The for loop is inside the while loop, and it tells it to do 15 of these every time. 15 of these in this shape, in this size, in this fashion. Then we'll loop back and see if we want to do more and what shape do we want to do this time, what color. So it'll count from 0 to 14. So it does 15 loops. So we can combine loops inside loops. All right. So if you want to practice with the loops, go to page 4, play with these loops, change things, see what happens to your loop, and practice those. All right. So that's the last page because this just says, look at the lesson and do the assignment. Okay, this week we have just a 5-question quiz. So if you're behind on the program or anything, this will be quicker this week. We've got 1, 2, 3, 4, 5 questions. All right. When should the while loop be used? What's the proper syntax for writing a while loop? What should it look like? Read this code, and there's an error somewhere. What should be fixed? So you may have to go back and look at page 4 of the lesson, like some of those examples, to see what's wrong here. As soon as the while loop conditions becomes what, the loop will what? Fill in the blanks. And then read this code and what output would be produced. So that's pretty good right there. All right, leave. There you go. So now you've got 4 loops that we learned last week in your rotor program, and we added while loops this time. So any questions on that? Kind of makes sense. You know, you can go in and play with it. You can go to that page 4, work with all the loops it's got for you there. But all right. If nobody's got any questions, this is a B week. So we have class Wednesday for those of you who need to be here or want to be here. So I'll be here then. Otherwise, have a great week. We'll see ya.